Right, well, in this box, as you can see, I have a Siglent unit. This has been lent to me by Rob of Teardown Technologies. Teardown is known on the EV block forum. Here's the New Zealand distributor for Siglent. And we shall open it up and see what we've got in here. So, packaging, usual stuff, right? Cable. And this is the unit. There's also some more cables in the box, which I'll get out in a second. So you've got this packaging, which is always moulded around the front and the back, so it always fits one way, so you can't get it wrong, and protects it really well. And there's some other cables also in the box. So we've got a standard USB cable for connection to the computer, and some clip leads, banana plug leads. Let's see what we actually have in here. So we've got spade tunnel leads with clips, and this is what we got. So that's the SPD1168X. It's an 8 amp 16 volt single rail power supply with external sense and grounding and computer control and monitoring, you know, and that sort of stuff. So you've got these tunnels here, so you can just stick the blades under if you're going to use that system. Yeah, it's in there. Not sure the blades are the best fit for these tunnels actually. They're a little bit wide. They should be slightly narrow really. The fork's a little bit wide, so it's not gripping particularly well. It's grabbing more one side than the other. Probably about a millimetre play inside there in the middle of the forks. Try this one. Is this the same? Seems to be. Yes, it's a little bit of loose in there, so it's only grabbing on one side. In case it grabbed on that side. These aren't the best. They're okay, I suppose, if you're going to use low currents, you know. But I actually personally prefer ring terminals, but on these, because these knobs don't come right off, they only go to the end. That's a good thing in a way, because it means you can't lose them. I think I'll probably replace these with some different ones. I don't like these forks, I'm afraid. Sorry, Rob. Sorry, Siglent. These aren't the best. If I do that quite tight. No, it's grabbed now. It's grabbed that time. Let's try that one again. Yeah, still not grabbed that one. Yeah, it's grabbed that time. But yeah, you have to just watch out for that on these, I think. But this isn't the kind of lead I'd use myself anyway. Not personally. I tend to use the banana plug leads. So these are what I'd normally use as this kind of thing. I just prefer them because they're pretty much universal. You can plug them into anything, you know. There you go, done. Obviously, put them in the way around, it'd be help if you're going to do testing. Red to red's always nice. Yeah, but I mean these leads feel right. I mean the PVC leads are not silicone or anything like that, but Cocktail clips, yeah, nice and strong. They feel alright. Yeah, feels like reasonable quality. Nice plugs, they're nice and large. I quite like that. There's a little grip on there to help pull them out so you don't slip off them. I quite like those. Bit of a strain relief on there, although it's not actually doing much strain relief because it's pretty stiff plastic. It's pretty rigid. If it's a bit more flexible, it will be better. I mean, there is some flex in there. It is winter here, so it's a little bit cold. I suppose if it's in summer, it will flex a bit more because plastic's softened with a bit of temperature. Sometimes it can make quite a big difference. The plasticizers that are used in plastics can be very reactive to ambient temperature. So even a small increase in temperature will make them much softer. So as you can see on the side there, there's Rob's sticker, Teardown Technology. So go to teartech.co.nz if you're interested in seeing what he's got available. He's got all kinds of stuff. I've done lots of videos on various items he's provided me over the years. Well, past year or so, I suppose, year and a half, 2 years. I guess I've been doing videos for him from time to time. So I've done various bits of gear, oscilloscopes and other power supplies and multimeters like the one I've got right now. The multimeter I'm using now as well, got from him and things like that. So anyway, we'll get this thing powered up and we'll actually have a look at it, shall we? Alright, so there's the back of the unit. So there's a couple of things I want to show you. Now, on here you've got selectable voltages, so depending on which country you're in you can set the voltages to suit your country. So obviously before you plug in the power you should always make sure these are set correctly. On the rear is obviously the USB port and the Ethernet port as well if you want to put it on your network. Because you can use, is it LabVIEW software I think it is, you can use on it. I have to read the manual for that, but I believe that's what it uses. And Siglent do their own software for the supply interfaces anyway. I played around with it a while ago and it's a 3-channel power supplier. It's all featured in there. So we'll plug in the power shortly. Another thing I want to show you, we've got the certificate of calibration comes with it. It's just for verification to say the factory's checked it and it complied. It doesn't actually tell you, you know, specifications as such. It just tells you that it's been checked, pretty much. And actual specs, as far as I can find in the manual, is this page here. So low noise apparently, less than 350 microvolts RMS or 3 millivolts peak to peak. Let's say it's 16 volt 8 amp, total power 128 watts it can provide, and it's a linear supply, not a switch mode. Transient response less than 50 microseconds. Minimum resolution 1 millivolts or 1 milliamp with 5-bit voltage and 4-bit current display. So 5-digit and 4-digit display, as you'll see when we turn everything on. And it's got timer functions and things like that. It's got 2.8 inch display diagonally, 240 by 320 pixels. So it's got 2 wire and remote sensing wires. So you don't have to use the remote sense wires. You can just use the internal sensing. You don't have to use external sensing. Can compensate up to 1 volt for the voltage drop across the wires as well, according to this. Intelligent control fan. So it's got a temperature control fan basically. So it only works when it needs to. Yeah, so you can store data as well. Safe setups, and we call them. And it's got the Easy Power PC software. And that's what it's called, Easy Power. Okay, so that's the overview on that part. We'll get the thing plugged in. Actually, one more thing I should mention before I turn the power on. It's got a nice clunking power switch. Oh, that's nice. That's a nice button. That feels really nice and snappy and responsive. That's a nice positive button. I like a good positive button. Got the power plugged in. Let's turn it on for the first time. Barely even hear the fan. It's really quiet. Really quiet. And there's a nice display. So let's go through it. This is the first time I use the unit myself, so we'll see if I can figure it out. So off, there must be unit supply. Yep, there you go. See it on off status. Although the button lights up as well. You can hear relay clicking. It's always nice. Relay switched output. 2-wire interface currently set, so it's got sensing voltage sense. Is that it? There we go. Yep. So now it does 4-wire sensing. And 2-wire, nice and easy to switch. Constant voltage. I'm guessing that means there's a setting somewhere to change that. Wonder where that is. So top looks like it's a set of voltages, and the output, the bottom is the output, the actual voltage, and the actual current and stuff. So that looks pretty simple, doesn't it? Really. Turn the output on. There it is. It looks fine. 3-digit resolution. Very nice. Interestingly, I've got nothing on the output right now, and it's showing a small load. So maybe calibration wise it's not 100%, I don't know, but with nothing on there you expect to see 0, wouldn't you? Okay, so let's have a look at what functions it's got. So fine, okay, that changes the cursor, which position it's on the top row, for when you're actually changing the voltages and stuff. So 16 volt max, yep. Oh, that changes which, okay, right. So fine changes the decimal place. Yep, definitely 16 volts absolute max. Yep, okay. So what's the lowest it will go down to? I have to hook this up to my multimeter and see what comes out of that. See what that says about the accuracy of the outputs. That's pretty small increments. 1 millivolt. Not bad. Okay, so then we got these arrows here to change which one you're looking at there for the settings. So you can change those. The same thing there. Looks like, yep, it's all simple, nice and easy. Okay. Timer on and off. So it does have a timer function, which is on this button here, which I have to look into. Let's push it. There we go. So you do controlled testing, I suppose. That means you can actually set a voltage and a current for a period of time. Let's say, okay, let's do 1 volt there, for example, and same controls. It works the same way. It's nice. Half an amp. Set time, I don't know, is that seconds? I'm guessing it's seconds. It must be seconds, surely. Okay, next row, yep, sweet. So let's do 2 volts, 100 milliamps for, still another 5 seconds. And it's got a little graph in it as well, showing what it's doing. That's pretty nice. Okay, let's go 10 volts for 200 milliamps for another 5 seconds. It's going to take a little while, so there you go, you can see what it's actually planned to do. And it goes back down to 1 again. Or 0. How far does it go? How many stages? 5. Okay. Alright, so that's that. Back to normal display. That's easy to understand, isn't it? Wave. Ah, okay. So you can see graphing of the output. I have to put some loading on this and see what actually happens, won't I? Okay, so let's go to timer. That was on timer. Turn it on. What does it do? I don't know yet. I need to figure this out, don't I? Timer on. There we go. So it's got a push button there as well. So it should step through each voltage. It does. Interesting, you saw the output change before the setting change. See that? You expect to see that one, then that one, or simultaneously. It's just the slight lag, but there you go. It's jumping between ranges on the transformers as well. So cool. That just does that one cycle and then stops. That's nice if you don't want to do repetitive testing on something. So what else is there? So you've got the CV up the top here. How do I change that? That's a lock button. Yep, there's actually a little padlock up here. You can't quite see it because of the angle I'm at. There we go. Right at the top of the screen. Hope you can see it there without getting the light on it too much. So these buttons are dual function, so a short press and long press does different functions. Apart from this one, because that's a short press all the time. Alright. Yeah, slightly different, but okay, that's easy to understand. So, version. Startup times 10. It's been turned on 10 times. Not bad. Okay, nothing else in there. Yep, okay. IP address settings. So if you put it on your network, it's currently set up for DHCP, so you can put it on your network and it will find its own IP address. It says page 1 of 2. How do I get to the next page? That one? No. It says 1 of 2 down here. Back end functions still working and I can't see them. Right, well that's pretty simple really, isn't it? Let's hook this up to my DC load and we'll run it through its paces. Okay, so I'm hooked up to my DC load, which is currently turned on. Well, it's not currently turned on, but it's hooked up to it. And I've also got my Siglent 6.5 digit multimeter running as well. So the DC load accuracy is a little bit off. It's actually slightly wrong. Monday I might actually pull it apart and see if I can calibrate it. But it's only slightly off. Now the meter's currently set to 10 volts. It says it's doing 10.001, so it's 1 millivolt over. Obviously it depends on the steps and the ADC and stuff like that. Or DAC, it would be DAC, wouldn't it? And my Siglent multimeter is saying it's 10.01 volts. So my 6.5 digit meter agrees with that. So it's saying 400 microvolts. So it's 10 volts, 1 millivolt and 400 microvolts or thereabouts on the output right now. It's interesting though, it says about there being a bit of a load on there. So, you know, that's a slight thing. If you worry about those really small amounts, then yeah. Now, I think I did actually just find a bug on this. Because when I turned the thing on and off, something came up on the display just here. So, right there, it's like a remnant left over. Which is interesting. It's almost like this kind of box here. No, it's in here. Waveform. I did the voltage sense thing, didn't I? There you go, there. That's coming up there, see that? Just here. I don't know what that's doing. Why is that there? I think that's a bug. So Siglent is a bug. Yeah. Anyway, turn it off. Don't know. But I did see it over here before. You just see a little blue dot just there. We actually kind of did it. And DHCP's off again. Interesting. Maybe I'm not actually doing a save or something. It's almost like there's like a shadow on display or something like that, where it's not quite cleared off. I don't know. I can't replicate it now. Sorry guys, but yeah, there's obviously something there which is. It looks a bit like that. That little blue box, you know, like. Now it's not coming up on there, so there's something somewhere. Let's do some testing. Right, it's been. I don't use this DC load very often, so it's been a while since I've used it. Unfortunately, the light's reflecting on it. I'm actually tempted to peel this plastic off, but I hate peeling plastic off screens. I tend to leave it on there to protect them, but it doesn't make for the best view, I'm afraid. So let's just see what we're going to do. 0.1 amp. No, can't set. 0.1 amp. Ah dear. Come on. Enter. There we go. That's what I'm trying to do. So that should do 100 milliamp load. The output is currently on the power supply, because that's going to see it. Let's turn this on. Constant current, 1 watt, 100 milliamps. That's fine. Voltage dips slightly because you're going to get a little bit lost through these leads, as you expect. Power supply still says 10.001 volts, as does my Siglent. Voltage has dropped about 200 microvolts on that one. And I would get that in shot as well, but it's up on the shelf. It's a bit hard to try and capture all three things at once. Alright, let's put some more loading on this thing. Right, let's go 0.5 amps. There you go, half an amp. That's now directed down, set to 200 milliamps right now. And the voltage has dropped down to 15 millivolts. And that's saying, well, 15.8 millivolts on this is 16 millivolts on there. So again, it's very similar. This is only saying 11 millivolts. So this is, you know, you can't really rely on the voltage on this to be exactly right, because it isn't exactly right. It's slightly off. So let's adjust the current. Let's go 500, 600. Here we go. So apparently the load is trying to draw out 503 milliamps. So okay, and the 500 there. It's just holding on. And yeah, there we go. It's dropped out. Just only just there. So if I just increase that very slightly. Five. There we go. 505 milliamps. My Siglent is saying it's 9.9999. So it's basically still bang on 10 volts. This is still showing that. It's dipping slightly now. It's got a little bit of load on it, but it's still really, really close. So the accuracy of this voltage reading on here is really good. And the load is showing a bit lower because obviously it's got the drop between the leads. If I wanted to compensate for that, I could actually run another set of leads up on the sense terminals, and I think I probably will do that if I can find some more clip lead ones. I'll do that in a minute. Okay, let's give it some more loading. Let's go 1 amp. And this can take quite a bit. This is the 300 watt load, so this can handle more than this thing can put out. The cables won't be able to handle it, but you know, it's the way it is. Okay, let's go 1 amp. Current set 1 amp. Here we go, 1 amp. 1.03. Voltage on the Siglent is, well, my 6.5 digit 3065X, which is 9.998. So it has dipped slightly. This is still showing about the same on the output on here, but it's dipping very little bit, just a little bit. And this is showing 9.95. Again, it's still really close. Again, it's only because of the leads. Let's go a bit higher. 2 amps, which is going to drop that out. Let's increase the current. 2 amps. There we go. It's doing 2 amps. I've just got this set slightly higher, a few millivolts, just to try and keep it just above that current limiting. See how close that can sit, and it's looking pretty good. So again, still showing exactly the right output voltage, and the Siglent multimeter still showing 9.995. So it's still pretty close. It's only 5 millivolt drop across there. Obviously using external sensing it should compensate for it, so we'll probably do that actually in a minute. Okay, let's go a bit higher. Let's go 5 amps. This could do 5 amps, so let's do it. Yeah, 5.05. So 5 amps output. It's doing it fine. It's currently generating 49 watts apparently, and the Siglent is still doing 9.985. So yeah, there's a bit of drop, but not much. Alright, let's max this thing out. I keep doing the wrong thing. 8 amps. Oh, come on. It's just like right there. I can't quite go there. 7.99. Oh, I did it again. 7.99. Enter. Now I should be able to do it. Okay. So there we go. 8 amps. Big voltage drop on there. I'm going to, losing nearly half a volt on there. Well, 400 millivolts or so I'm losing on there. And it's doing it. And my multimeter is saying 9.976. Seems fine. Okay, so it can do 8 amps at 10 volts. Let's increase the voltage, shall we? And see what we can do there. 16 volts. It's an absolute maximum. So 128 watts is what most it can do. This is really maxing out. If it's going to go bang, it's going to be now. So it says 125 watts being delivered. Because this is the way, this is obviously not accurate. And the multimeter is showing 15.9779, or 978 really. It's generating that power. Although it's saying 125, but it's voltage drop and stuff. So cool, it can handle it. And the fan, you can barely even hear it. Barely even running. So I'm going to hook up some other test leads and we'll do some sensing checks and we'll see how it goes. Well, I've got a set of clip leads hooked up onto the load here. So we'll turn it on and turn the sensing on. So first do normal without sensing. So say it's 15.649 and we'll turn the sensing on and repower the power supply. It's now doing 15.989. So 15.99. The Siglent is saying 16.322 output. That's saying 16 there. Obviously it's programmed to only show up to 16 to try and show what the actual device is seeing. And that's fine. That's now generating 127.75 watts. That's what you'd expect to see. Shall I load test it to see how long it can actually produce the power for before it starts to chuck that fan on really loud? What do you reckon? I think that's going to be an idea. The other thing I want to do is do a load sense directly on these front terminals. So let's just do that too. We'll change that around. Get some more clip leads. Or some more banana leads. And we'll just sense straight on the front terminals and see if that changes much. So excuse the colours, this is what I have to hand. Right, so let's just try that again with sensing straight off the front panel. Now the Siglent is now seeing 16.001 volts. So straight off the front panel there, that is bang on. So yeah, that is absolutely fine. So it's sensing itself right here, no problem at all. So I'd actually be inclined to get some of those bars, little banana plug bars that go across between them, those little flat bars with the slots in. So you can jumper those pins together on those two and on those two and just leave the external sensing turned on. That's what I'd be inclined to do, because that's going to be most accurate on those terminals then. If you're really worried about it, then you know, you could do, just do what I've done previously and just run it straight to the device you're actually testing. So this is currently on, doing 128 watts or so. I'm just going to leave it running for a little bit, maxed out, and just to see how it goes as far as the cooling fan. Hopefully it doesn't blow up. It shouldn't do. It should be able to handle it just fine. I'll be really surprised if there's any issues with that. But I can hear the fan winding up now. It's still really quiet. It's a very quiet fan. I can feel a little bit of airflow from the side. It blows out the back, you see. So it sucks it in from the sides and blows it out the back. The air coming out the back is not really even warm. I don't recommend you normally do this. I don't like running things at the maximum normally. I like to always stay within the limits. I don't like running things right to the limit of what they can do. But it's designed to do this, so it should be able to handle it. Fan's getting up there. Fan on this isn't running that much. It's pretty quiet, really. Most of that noise is from this thing, and even then, so it's not that loud. It's fairly warm, so the cooling seems to be adequate. I mean, it's not really struggling. It didn't like ramp up really quickly, so obviously it's not overheating rapidly or anything like that, even at full loading. I think that fan is at maximum speed now. It doesn't seem to be ramping up anymore. Yeah. These cables. Yeah. Checking for warm spots in the wires. You don't quite know. Not sure the cables can handle 8 amps continuously like that, but they seem okay. There's a slight bit of warmth in there, not much. Don't melt the cables in the process, do I? That'd be bad. Yeah. Yeah, I think that's the fan maxed out. So what we'll do is we'll disconnect this. Interesting, that fan kicked right up when I did that. I wonder if it's loading down the internal power supply when it's doing that. So that noise now is just that unit. Just all set, yes it is. I think so anyway. That already dropped down again. So it's obviously cooling down pretty quickly, so it must have some good cooling in there. Must be very effective. We'll be finding out because I'm going to be doing a teardown on it. So I've got it on full load again. Yeah, it all seemed right. I mean, the air coming out the back is barely warm. In fact, it ramped down so quickly afterwards. Means it's probably handling it just fine. But it's interesting the way that that fan sped up when I took the load off. So it's probably loading down its internal power supply. I might actually do a test on that once I've got the thing apart. If I remember to do it. Now you're listening? Hear that? Interesting, isn't it? So it must be loading it down slightly. But it seems adequate. I'm not really concerned by it. It seems fine. Right, so I've been given permission by Rob to do a teardown on this thing. So we'll get into it. Now this doesn't use Phillips screws, it uses Torx screws. And it's a T10 according to my set here. Because that seems to fit. A little bit loose, but it fits. And it'll be exactly right. But anyway, let's get the thing apart. It does still have the factory seal on it. I've been given permission to break that seal, which is great. Rob actually suggested I pull it apart. He said, hey, go on, open it up, go on. So that's good. So you get to see what's inside one of these things. I will try and preserve the factory seal if I can. I would like to put it back on if I'm able to. But we'll see how we go. If I can peel that off nicely, and I'll do that. I'm still working on getting this camera settings right. It's I've improved the lighting. I've got some much brighter lighting in here now. It does about 1800 lumens. Which has helped a lot because I'm only using a small aperture size in order to try and increase the focal range. I think I've got to screw that side, haven't I? Yep, 4. So I've got one screw left here to take off. I'll do that after I take this label off. Now, how am I going to do that? I think I've got some razor blades here, so I'll get one of them. Right, well, I found a blade. Let's see how we go with this. I'm going to use my hot air station as well to warm it up and soften the glue. Improve my chance of getting it off. Just very slightly, I don't want to put too much heat into it. Just in the area. Just to help soften it a little bit. Okay. Also the other panels, so I'm trying to suck the heat out. Right. Let's see how we go. Get the right angle so not to get into the paint. It doesn't really matter anyway, because I say Rob did give me permission to open it. But I just want to see if I can do it. It's one of these things that would be nice to know. Maybe people will appreciate it, I don't know. It's cooling down now, it's getting harder to do. Yep, it needs a bit more heat again. This is winding down to turn it off, but it's ramping. Let's try this. Yep, that's better. Heating up definitely seems to help. There we go. That's off. That's off and it's stuck to my razor blade. Now I've got to get the razor blade out. Come on. Here we go. Done. Of course, I never showed you how to do that. If anybody asked, it wasn't me. And I kind of learned to do that from Dave. I'll just put my little twist on it. Now it's just going to slide back. How does this cover come off? Doesn't want to come off. Is it screwed through there too? It might be. I'll be right back. Right, another screwdriver. This is a T15. Yep, that fits. It feels like it's not going to drop a nut off inside, which is always nice. So I think this is probably what's holding the casing on now. Right. Metal reinforced strap, is it? Yep. A bit of stainless in there. That's what you'd expect it to be. Now, will it come off now? Yes, it will. For that, put that to one side. Looks nice enough. Nice big toroidal transformer. Because this actually balances really well when you pick it up. It's just beautifully balanced. So they've actually got the weight distribution really nice inside there. So, oh, device standing up on its end, I don't like that. I don't like having devices stand up on their ends. I mean, it seems rigid enough actually. It doesn't seem to be wobbling much, but I just don't like it. It's a MOSFET of some kind, I think. Trying to make the bloody numbers out. I can't see what it is. But what are these ones here? RFP150N. Okay. And there's a thermal sensor right there. Big glob of something over it. Feels like Celastic actually. Yeah, it's Celastic on there. Interesting. Hope it's got a screw behind it. I'm not going to peel it off to find out. And connections are glued. And I don't see any Siglent rust, as Dave puts it. The thing about rust, right? The thing that Dave made an issue of the rust on the edges. Having worked in metal pressings many years ago, I know that this is just stamped out of a sheet, right? You get a big sheet. It could be on rolls, which comes off various widths, or it could be on a big sheet, which is like 6x12 and stuff like that, or whatever, or panels. And it just gets punched out. And when it gets punched, it may come like this, where it's all been galvanised or anodised or whatever it is before to protect it. But when you punch it, it breaks that seal, and there's none of that sealing around it. So the actual this protection that's on the surface here, it isn't where it's been punched. That's just the way it is. That's the nature of the process. It comes pre-protected. You don't protect it after the punching. So which is why you see that rust there. Normally also the sheet steel, it has a coating of oil on there, some kind of mineral or something on there to help stop it rusting, corroding, that sort of stuff too, just to give it a bit more protection. Now when you're punching, a little bit will get dragged through the punch and it will help protect it and coat it, but not 100%. And also a lot of processes, after they've actually done the stamping and punching process on the machines, they'll go through another process which is to actually take the oil off it. Okay, so it's nice and clean for the customer, so the customers don't get bits of sheet steel which are covered in oil. And it's from that point onwards which is when you can get potential, rust going on there. It's just part of the process. I mean, I think it's being a bit harsh to say, hey, there's a bit of rust on the punch line. Well, that's just the nature of it. This coating isn't on the punch lines, right? Like in here, those edges here, those are punch lines. Okay, that is within the sheet steel, which has just been sheared out of the sheet. So it's just the nature of what it is. I mean, I think it's being a bit too critical, really. But anyway, depends on the environment. I mean, maybe the time of year where it's really humid, you might get more rust. Maybe that's why it comes and goes. I don't know. Anyway, that's just my take on it. So, a couple of big storage caps there. What brand are they? It says LSM on there. Can't see the brand. Probably Lelong. They tend to use Lelong caps, don't they? These are Lelong caps. So that's Lelong caps. That's Lelong. So yeah, it probably lead on. I don't know. I can't quite see. I can't see any brand on these ones. Not from the angles I'm at. Sorry about that. So there's a big bridge rectifier right there. It's got a multi-tap obviously on this toroidal that switches the taps. This is on the input board, so switching there is for the inputs on these. So that's the primary side. It's all nicely protected. It's got this plastic sleeving over all the wires. You know, it's a thick plastic PVC sleeving. Goes right through. That's a really nice touch. I really like that. That's good protection, good insulation, and you can still see the colours. That's a nice touch. That's protected. Heat shrunk terminals. That's all nice. It's got a built-in fuse holder on the back there. That's all fine. So there's that big clunky switch. Very nice. And even that is glued on that shaft to make sure it's all nicely done. Inline fuse just there. Unfortunately it's not in a holder. I would like to have seen that in a holder. Although it's easy enough to replace. What value is it? I'm trying to see. I can't even see it marked on the board actually. This says F1. It says 250 volt, but that's not exactly uncommon, is it? You better see it when you take it out, I expect. Plug there is okay, that's right. All glued in. I think actually that one plug there, the J9, that's not glued in. That J2 plug over there also isn't glued in. All the other ones seem to be. All the other ones have got glue on. So it looks like they've just missed those two. They've got some elastic between those caps down there as well. A couple more on-end transistors, or MOSFETs, whatever they are. Can't see what they are. That's nice and rigid. This one, yeah, okay. They feel really solid. They're not want to moving. They don't want to move. So that seems okay like that. But I just don't like that whole principle of not having them attached to something. You know, even if I just put a little vertical heatsink off the board straight up, you know, it will take years before anything happens. Years and years, but. And there's another fuse down there next to those relays. Zoom in a bit. Zoom. Right, here we go. Need to have sound effects. Okay, so right there is another fuse. Can you see that? So it's got dual protection fuses. So one's probably secondary side, one's primary side, I'm guessing. It's marked as F2. No ratings on it that I can see. And that's a ceramic fuse. So that's most likely the primary side. You've got input marking here, output marking there. So that goes to transformer side. Yeah, okay. Got some MOVs, as you would expect. There's a little buzzer under here underneath this ribbon cable. Looks like a capacitive dropper, possibly. There's a big capacitor there. Could be filtering, but I don't know. Maybe filtering. And from this side we can see what. So there's that. It's BTA08, I think it is, -600C. If anyone wants to look that up. I might even do it later on, who knows. Might fill in the video with that. Cooling fan, there's no real mountings on that. It's straight to the chassis. It's using these locking nuts. You've got like a textured surface on the base of the nuts so they grip into the plastic so they won't unscrew themselves, which is a nice touch. As I said, that fan was pretty quiet anyway. It wasn't actually that noticeable. It was pretty good. A whole bunch of surface mount stuff under here underneath that transformer. Try and get it in shot. See under there. And it's got some optional resistors here, look. Try and get the lighting on it right. What is marked as RT1, RT2, RT3 and RT4. Only one of them was populated. And it's looked like current shunt resistors, so I'm guessing they had different options for how they're going to configure it. Maybe they use the same board and different power supplies. Maybe they had the idea of doing higher current ones or something as well, so they needed more shunts, or maybe they thought they needed to have more resistors to go through to spread the loading, but found that one was adequate, they could do it with one. Entirely possible. Bit of elastic between those caps there too, it's all nice. I'm not going to take the main board out, just like a bit of a mission to get all that part right out there. Not want to go that far. Get that cap out, it's nothing to do with this. My junk lying around. So the terminals, B and C's, go straight onto this little sub-circuit board just here. Soldering looks absolutely fine, looks good. And which then goes through, it's actually going through the board, so they've got slots in this board here, and those traces are going through the board, and they're also going to be soldered underneath. So that all looks absolutely fine. If I try and wobble these around, can't see any movement. No, it's all rock solid, all looks good, it looks all absolutely fine. So the little flex cable goes to the front panel here. Can I see the front panel? Or shall I pull that apart? Okay, what do you reckon? I think I should do, if I'm going to do a teardown, I should pull the thing apart. Should go that far. It looks like I can probably get the thing off. We can risk it. We can have a look. Let's see if we can go, Let's see if we can get this out. So yeah, that's that T10 again. There's a screw right there, which could be an awkward one. We'll see if it matters. We'll do that one last. So I might just try and take the whole panel off like this and see if that'll get me to them, Oh, there's my password front panel. We'll find out. We'll see what moves, Take that off there. A couple of machine screws for those. Is this going to move? Don't know. It's got some movement there, not much. There's a screw under there that might go to the panel. There's only one way to find out. It may just be a bit of a mission to get the thing apart, and I might not bother. Alright, there we go. It's starting to go. Cool, it moves. Right, so it's just take this flex cable off. Now I'm definitely going to be lifting the thing out. Oh, it's got this tape all over the place, isn't it? Which is good, because it means it's not going to fall out on its own accord. I'll come back after I've got this, I don't want to bore you with this too much. Okay, so I've got the ribbon cable out. Now I've got to get the front panel off. Now I'm going to have to take this button off because it is smaller than the hole in the back of the front panel. But I think the rest of it will come away. So I'm going to just prise that button off and it should be okay. So let's just get in here with my needle nose pliers, as someone once called them. Don't want to be pulling directly on a switch, without taking it easy. It's like a chewing gum kind of glue. It's taken a bit to actually get that at the break. Here we go. Here's the front panel. And that's what the end looks like. Hopefully it's in focus. It may not be. But so it's got a plastic reinforced mounting there. And yeah, I was right, that screw that went through the bottom did hold the front there. So yeah, all looks fine. I mean, gives you another view there, doesn't it, of the guts of it. Hope it's in focus. Right, so let's put that to one side and we'll carry on with the front panel. Get this piece apart. And hopefully I can get it back together again. I'm sure Rob would like me to be able to get it back together. Yeah, I'm pretty sure Rob would like it back in one piece and working. That kind of thing. Fussy, fussy, fussy. There's a piece of tape here, I'll pull this off. Like that. Okay, here's the front panel. It's got a nice bit of bushing in there to protect it from wear, so it's not rubbing on a sharp edge. Otherwise things like that happen. And no apparent rust. Sorry, Dave. And there's the front panel. Again, tape on the LCD display connector there. Some kind of driver here. There's a button. No, I can't quite read that. something C595. 595, so I recognise the number 595. Something I was going to play around with at some point. I haven't got around to it yet actually. So you've got some spring terminals on here, which is obviously for the grounding, so it's grounding against here, which is a nice little touch, helping ensure it's got good shielding. There's an interesting small S5 little pad there. What is that for? Let's take this off too, eh? Shall we? So look under there. That's the pot on the front there, so I need to get that knob off there. Need nice pliers. Use them a lot because they're really good for things. Okay, fold this over gently. Careful when touching. And there we go. So it's got some plain copper pads on there, probably gold plate, and carbon membranes, as you would expect. A nice little rotary encoder there. Yeah, so there's not much to see under there really, is there? Here's a display. Is it 302.033.00024, which is also XZSHDAI, and it's got MD028TL42-40NK-04A, in case anyone wants to follow along with that. But yeah, I'm not going to take that out. It can stay exactly as it is. Right. Hope that was exciting. Was it worth the effort? I don't know. Was it? Maybe. Let's get the screws back in. All the screws seem to be the same. There's no obvious differences between them apart from the machine screws that went onto the sheet metal. So that all looks nice and easy to put it back together. So my impression of this is that it's nicely built. It looks like it's nicely designed apart from those transistors which stand up on their ends. I prefer to see those mounted against something, but it's quite a common thing these days, and lots of things, I don't know, I'm not sure it's the best approach. Put that back down. It should sit nice. Yes, it does. It should sit nice. What's that? That's a spring contacts, of course it is. Right. So the spring contacts are actually working because that's actually holding it up. So those are actually doing the job. It's got some little locating dowels there and there to line the panel up as well. Another nice little touch. So it seems to be a nice little power supply. So if you're looking at something which does, well you need a supply which does up to 16 volts and up to 8 amps, then this could be for you. Resolution on the front panel is good, accuracy on the front panel is good. Okay, so we'll put this back together, and no signs of rust, I think. Oh, hold on, no, there's just a little touch just there along that edge. But like I say, that's part of the process. You know, you can't really get rid of that very easily. You know, I don't see a problem with it personally. You know, as long as it's not out of control, it's not all over the panels. You know, if it was all over the sheet panel like this, you know, then I'd be worried about it. But right on the edges like that, it's like, well, that's nothing. It's just, that's just the way it is. That doesn't worry me at all. You know, if you had experience with sheet metal work and metal pressings, which is something I did many years ago in my youth, you'd actually understand it and then understand why it is the way it is, and realise it's actually not a big deal. It's just the way it is. It's not a problem. Okay, I'll slide back on there. Get everything realigned. Drops in nicely. We get these top ones in first. All these screws, the machine screws, also the same. So it's actually nice to use the same screwdriver basically for the whole thing, you know. So there's all, you know, T10 Torx. That's the whole lot. So apart from those ones that did the handle, because those were, what were they? 15? T15. So it's actually nice to see that simplicity as well, because it's multiple options, well, multiple benefits from doing that. Reduce the BOM cost means you can buy more of the same thing from a manufacturing perspective and pay less. You know, you usually buy larger quantities, you pay less for it. You know, I'll do them up tight in a second. And it also means simpler assembly, because you can just grab a screw and chuck it in, because you know it's going to be the right one. Go. Put the ribbon cable on and we'll power it back up, make sure it still works. I'll put the button back on in a second. I need to put some tape off on there too. Pull that piece of tape off. I have to replace it. Okay, that's slotted in. Clamped in. Just checking it. Looks like it's in fully. It looks good. Put the button back on. Doesn't matter which way up it goes, or is it universal? Well, the glue is at the top, so I'd put it back that way. Then I'll re-glue it, of course. Right. Let's get a power cable and let's make sure it still works before I go any further. Fingers crossed. There you have the screen. There we go. It still goes. Output. Yep, still there. All good. Controls work. Yep, sweet. No problem, I didn't break it. Awesome. Right, so there you go. Put it back together. All the screws are back in. None left over. That's always a good sign. Seal is back on. Never even know it's been opened up. That'll probably please Rob too. So this is a nice little power supply. Well, the only thing I've got to do yet is play around with the networking and try it out with the software, hook it up to a computer, and just run it through that as well, and see what kind of readouts we get and stuff like that as well. That's not something I'm big on myself. I don't tend to use that kind of feature. I've played around with it a little bit on a couple of things I've tried out, but it's not something I normally use. So it's not my strongest point in that, you know, playing with the software side of things. There's no reason why, you know, you shouldn't just have a play around with it and give it a go. You can see if it works for you. So I've got the software somewhere. I'll probably have to download it actually. I might have an too older version from when I did the last power supply reviewed. I'll get to download the software, hook it up on the PC and play around the PC software, so I'll do that shortly. But yeah, my impression of this power supply is that it's nice. I like it. If I didn't already have a decent power supply, then I'd certainly be looking at one of these. To give you an idea, the one I've got is over there, and it's it does 15 volts, but it does up to 35 amps, and it's a linear power supply. So it's a big thing. It's an Astron VS35M, variable volts and stuff on the front panel. You probably see it in my videos in the background. Actually, I might just swivel this around, you can see it. Well, it's a bit messy, but you know, yeah, it is what it is. There it is, sitting right there. That beast. So I've got that big beast there, which does high current, and I've got this one here, which is obviously my lab supply, which is triple output and stuff. Not as nice as the Siglent one, but it's okay. The next thing we'll do is play around with the software. That'll be tomorrow though, I've run out of time today. Okay, so this is the Siglent America website, which is where you can get most of the files and stuff you need, like support documents, things like that. So this is the page for the actual power supply, and a bit of information here, stuff which may not be in the manual maybe. Setting accuracy, for example, I think I saw that in the manual. There's only a quick start guide we had, so the manual was actually downloadable. I'll go to that in a second. And reading accuracy as well, gives you information there, and the price in US dollars from Siglent America. Price may vary in different countries and things like that because of exchange rates and import duties, that sort of stuff. And obviously a close up of the actual unit there. Now down the bottom here, it shows what it comes with, you know, power cord and stuff. So although this one had clip lead stuff with it as well, so I'm not quite sure. Maybe they do come with it, maybe they don't. They seem to be included with this one. And then down the bottom here, you got firmware and software and documentation and tips and things like that, and some support videos too, apparently. Although I don't know if it's actually any for this one. I should actually have a look. We'll have a look in there, see what's there, see if there's one for this unit or not. Yeah, there is. There is one here for this unit too. So Siglent got a little video there. It's probably Jason Chonko. He's the one that usually does those videos for Siglent these days. It's more appropriate to what they want to do. They do present nice videos. They do present things quite nicely. So here's a quick start guide, which we got in the printout, which came with it anyway. So this is the same thing. It's exactly the same thing that came with the unit, like just an electronic version of it. So we can get rid of that. That's downloadable. User manual, which obviously has more detail in it, more spec information, more usage information, that sort of stuff. It mentions about setting this up for the remote sensing and stuff like that, which is what I've already demonstrated. Setting the LAN stuff up. I've already put an IP address stuff like that into it for my LAN, for my direct connection to my computer. but when I'm on computers, I'll try it on the Mac first. We'll see how we go with that. I'll do some video on that if I can get it working on the Mac. Interestingly, when I've done this, I'm not using DHCP, I'm using manual entry, and it's not showing up in this top part here. It's not showing, but the bottom part is, interestingly, but it's probably the same I'm doing. And you've got the saving function. This is the screen I didn't actually show. I might go back and show this when I go through it. That's that second screen I was saying I couldn't forget to get to. Well, if I'd read it properly, press and hold the IP save button to display IP page from the store page. Right, and the store page has got press and hold IP save button, display store page. Right, so yeah. So if I'd read it, well, I would have seen exactly how to get to the second page. I was just glancing over it. So anyway, it tells you to do that sort of stuff, and it's all in the manual. I'm not going to read that to you, or you can look at that yourself. But it's all available online. Just go and download it. Firmware updates are available. And this is data sheet, isn't it? This is a data sheet for the unit, just not like an overview as well. A bit of a demonstration of some of its features, I suppose. So low ripple and things like that. So it's hard for me to measure noise on power supplies in my lab environment here because it's very noisy. I've got a lot of RF gear in here, Wi-Fi and that sort of stuff, and it causes a lot of common mode noise in the area. It makes it really hard to do precision readings. So me trying to show the noise levels on this is probably going to be impossible, because I'll just have so much ambient noise in the area to mess up the readings. And there's proper specs and stuff here for it here. So there we go. So that's all available. Download. If you want to have a look, go and download it. And this is their documents download page, which is where I found those files down here. And that's those informations there I sort of showed you. And you've got 4 different power supplies as well. I reviewed this one here, 3303X is the other one I've reviewed previously. There's a nice little power supply too. Firmware and software downloads, again you got just their general page, and it's got all their firmware for all the different devices here, in this case the power supply section, and it's got firmware updates. The firmware in this unit is the current version, this one here. It is already up to date, so I don't have to worry about doing that. And this is the Easy Power software which I need to download and put on the PC. At least I believe it's for the PC only. I don't think it goes on Mac. I'll have to have a look yet. So Siglent America, siglentamerica.com is the web address. So go there, and if you haven't already got that address, or you don't know about it, you might find it interesting.